Step one for this activity is having the students get particle trails for materials that they know the size of. So if you can give them, I like to give them 5 different sizes from what I call extra small to extra large, and actually run multiple trials down the ramp at high acceleration, and then multiple trials on the other side of the paper or on a different sheet of paper for low acceleration. And so get the kids to make sure they're always controlling their variables and running from the exact same spot. It's good to have something to catch the ball. It's okay if the trails cross each other, because obviously there's going to be crossing later on. So now we're going to actually start a collision, and to do this the students will decide what particles are going to make up their particle. So let's say they're going to use the extra large. The trick here is placing it so it doesn't roll around, which takes a little practice. Some of the first collisions are going to have a lot of white noise data. So I've got an extra large, got the medium, I've got the small, and it really is hard to place these without creating marks, but they get better at it as they practice. So I'm going to use high acceleration, hit it with the large. See what I mean? One little move. But you're getting the idea. So large ball, high acceleration, accelerating down into my particle, which happens to be made of the extra large, the small, and the medium. Lining up the accelerator to actually hit the beam. So not only do you need the beam intensity, you need it to be lined up so it'll actually hit where the detector is, or where the target is. So roll it down. So a lot of the students here will take a picture so they remember what was there, and then they'll film, or they'll just film the whole event so they can have a record of what happened. Sometimes not all the particles will actually leave when you have an event like that, and that's okay. Just try to pick them up without causing too much problem as far as marks. So probably not the easiest thing in the world to see, but you've got the large coming in. So I usually have that marked, high acceleration, okay? And then you've got what's happening. So I see here, it's coming in, and then it bounces and goes off this way. And then this other particle here went this way, and large went that way. Takes a bunch of these collisions to really start wrapping your mind around what happened, even though you just saw it happen. When you go back and you look at the data, it's like, now which piece was where doing what? That's where these sheets can come in handy too. They can compare and see if any of these tracks look similar to these tracks. The more collisions they can do, the better. And then ultimately what you're going for is when they get pretty comfortable seeing what it is they just did using the detector methods they have, in this case the what would be analogous to the cloud chamber tracks. Then they're going to make one where they know exactly what happened, but no labeling, no nothing. They'll make a key, and then they'll swap with another group that did the same thing, and they can see if they can actually figure out what happened based on all their evidence. And the really cool thing is if they take time, they really can figure it out, and they get pretty excited about it, and it's neat to see. So they're doing the exact same type of detective work that the scientists would have done back in the days of the cloud chambers and looking at those cloud tracks. With the cameras, it helps so they can go back and look and remember what happened. And that's pretty much it. So have fun with it.